Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudewa Sos Ugobela Mced. And without any further ado, let's look at these questions that we have here. Ah, okay, so we have question 4. It says, a pendulum with a bob of mass 3 kg is kept stationary at a height of 1.2 meter above a surface. It is released and at its lowest point, so check there. It is released, so it was kept stationary, and at its lowest point, it collides with a block of mass 1 kg, which is at rest on a frictionless surface as shown in the diagram below. Ignore all effects of friction. So this is a frictionless surface. There is no friction. And then 4.1 says, state the principle of conservation of mechanical energy. And then we simply going to say, this states that in an isolated system, the total mechanical energy is conserved. Right. So that's how we have that. And then 4.2 says using energy principles only, calculate the speed of the pendulum bob just before it collides with the block. So understand this. They said this is a frictionless surface. And then the one formula that we know we have to use whenever we are dealing with objects on a frictionless surface is obviously the principle of conservation of mechanical energy. And you can see the hint that I've been speaking about, that the examiner will always give you a hint as to which formula you need to use to calculate. So you see in 4.1, they just ask you to define the principle of conservation of mechanical energy. And it happens that in 4.2, you also need to use that same formula, right? So that means you're going to start by saying the sum of mechanical energy at point A, so that's before, is equals to sum of mechanical energy at point B, right? So obviously this breaks down to mgh initially plus half mv squared initially, and then equal to mgh finally plus half mv squared finally, right? Now, what is our mass? We are told that the mass of this bob is 3 kg, then multiply that by 9.8. Then the height at that point, we can see it is indicated 1.2 there. And then plus half, we have our mass here, 3 kg again. And then velocity initially, remember they said this was kept stationary and then it was released. So that means the velocity initially was 0. Then here we have 3 and then 9.8. The height finally, obviously, when it reaches this point, will be 0. And then plus half, our mass is 3. Then what are we trying to calculate? The speed. So the velocity after, right? Or the speed after the collision, as we can see here. Okay. So in this case, so, okay, not after the collision, but then before it collides with the block. So this was before here. And then after is just right before it collides with the block. Okay, understandable. Then now we have to calculate this one. 3 times 9.8 times 1.2. And then add it to that. We are going to get, so in your calculator, let's check. 3 times 9.8 times 1.2. That's equals to 35.28. 35.28. And then here, this is half of, so this will be 0 right here. And then what is half of 3? It's 1.3 VF squared. Then if we divide both sides by 1.5, so the answer that we got divided by 1.5, this will give us 23.52, and then is equals to VF squared. Now we know that we are looking for VF, so we can square both sides like this, And then our final velocity would have to be 4.85, right? So this is 4.85 meters per second. And then this is the velocity just before it hits the block there. Right, so makes sense. Okay, now they say after the collision, the pendulum bob has a velocity of 1.8 meters per second, right? So after the collision, the pendulum bob has now a velocity of 1.8 meters per second, and the block moves up the frictionless curved ramp until it reaches a maximum height. Now we know if it reaches a maximum height, its velocity will be zero, right? Because the velocity at the maximum height is always zero. You know that from vertical projectile motion. As shown below, assume that no loss of mechanical energy occurs during the collision. 4.3, another definition. So in this question here, we've been given two definitions, which is nice. That's 4 marks for free. And then we're just going to say principle of conservation of linear momentum states that, okay, so let me just say it states that the states that in an isolated system, what's going on? In an isolated system, the total linear momentum is conserved. So right. So that's our definition right there. That's our definition right there. States that in an isolated system, the total linear momentum is conserved. Now, 4.4 says that calculate the magnitude of the velocity of the block just after the collision. So if we are talking collision, we know that this is where now we have to use the principle of conservation of linear momentum. Again, look at the hint. They just made you state the principle of conservation of linear momentum. And the next calculation that follows, you have to use the principle of conservation of linear momentum to calculate that. So always be mindful of those hints that are always dropped by the examiners. So this is momentum initially. Sum of momentum initially is equals to sum of momentum finally. Now, which case is this one? This is where both objects were moving individually. So this is just M1 V1 plus M2 V2. And then even after collision, they're not moving together as a unit, but they're moving individually separately. So that's what we have. But then remember the bob, we did calculate from before that just before it collides with the block, it had a velocity of what? 4.85, right? Which is the one that we calculated from above there, 4.85. And then the mass of the block is 1. But then the velocity of the block at that point, remember the block was just stationary before the collision. But then after the collision, this is our bob. And then they say now it has a velocity of 1.8. So we have 1.8 here. And then the mass is 1. And then we are looking for the velocity of the block after the collision. So we are going to punch that into our calculator. That's 3 times 4.85, which will give us 14.55. And then this here is 0. Now, what is 3 times 1.8? So this is a 5.4, and then plus V2. Now, if we take this one and transpose it over, that's 14.55 minus 5.4. And then the velocity that we are going to have is 9.15 meters per second. Right, and that's how you were supposed to calculate that. Awesome. So that's how you could have got that 4 marks. Okay, and then now let's proceed to 4.5. It says calculate the vertical height. Calculate the vertical height reached by the block. Again, we are still on a frictionless surface. So to calculate the height, we would have to use the principle of conservation of mechanical energy. So we'll say mechanical energy initially is equals to sum of mechanical energy finally, right? And then this will obviously give us mgh initially plus half mv squared initially is equals to mgh finally plus half mv squared finally. Now, what is our mass? Remember now, we are looking at the block, right? This is the block. So 1 and then 9.8. What was the height initially of the block? When it was still here, the height was just 0. And then now we have half, our mass is still 1. The velocity initially, at this point when it is struck by the pendulum is the one that we calculated. And then we found that it was 9.15. So 9.15 square. And then our mass is 1. G is 9.8. So we are trying to get the height finally. Then plus half 1. Final velocity, they're saying it reaches a maximum height. We've already spoken that maximum height means the velocity finally there will be 0. So this is 0 square. Now, if you punch this into your calculator, this will give us, so what is half? What is half multiplied by 9.15 square? We find a value of 41.86125. So I'm not going to round off because it's not the final answer. And then here, this will just give me 9.8 height finally. Then divide both sides by 9.8. 9.8. My height finally now, if we take that and divide by 9.8, so answer divided by 9.8, that's 4.27 meters. Right. That's how you were supposed to calculate that, correct? So that's the height of that is the height reached by the block. Okay, so that's how you were supposed to go about answering all of this question for a total of 15 marks. So you know what to do. Press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.